The current which is passing through this ammeter is 0.8 and the resistance is 3. So V is equals to IR. So the current is 0.8 and the resistance is 3. So 0.8 multiplied by 3, which is equals to 2.4 volts. So 2.4 volts here and same 2.4 volts across 2 ohm resistor because they are in parallel. So if voltage here is 2.4, same voltage. If I connect any, if for example, if there's another lamp was there, that will also have 2.4. If there was another resistor, that will also have 2.4. If I connect infinite number of components to this, all will receive the same voltage. Then what happened? So the answer here is 2.4 volts. Current I3. If we need a current I3 here, means we need a current in this one, which is I3. And we already know the voltage. The voltage is 2.4 because they are in parallel, so they have the same voltage. So we have the voltage, we have the resistance, we need a current. So again, we'll use the formula V is equals to IR. V is the voltage, which is 2.4. I is the current, which we don't know, which is I3 here in this example, and R is the resistance 2. 2 is multiplied, other side it will divide. So 2.4 divided by 2, that's equal to 1.2 amperes. So you can see when the resistors are connected in parallel, as we work out the current which was flowing here was 0.8, and the current which is flowing through I3, sorry, 2 ohm resistor, which is I3, it's equal to 1.2. So what you can see if the resistance is high, then small amount of current can pass through that branch. If resistance of the branch is low, greater amount of current can pass. Now, what is the value of I1? What will be the value for I1?
I2 plus I3.
I2 plus I3, which is 1.2 plus 0.8. So that's equal to 2 amperes. So this will be 2 ampere. And what is the reading of I4 or value of I4?
2.
That will also be 2 because we in the beginning we mentioned both have the same currents. How I can calculate this I3? Because the current was given in the question, this current was 0.8. So I use the formula V is equals to IR. I got the voltage, which is 0.8 multiplied by 3 equals to 2.4. So means the voltage here was 2.4. So they are in parallel. How much voltage will be there? 2.4. So I have the voltage, I have the resistance. So I can use the same formula. V is equals to IR. V is a voltage, which is 2.4, and I is a current, R is a resistance, which is 2. So 2.4 is 2.4 is equals to I multiplied by 2. This is multiplied, other side will divide. So what I will get? I will get 1.2 amperes. Next, the resistance R. We need this value. You can see the weightage, it's a 4 marks. Why this is having 4 marks? Because you have to work out first the voltage here, then you should know what is the current here, and then find the resistance. So the current was 0.8 here in the first branch and 1.2 in the second branch. So what will be the current I4?
3. 2.
2 amperes. And what about voltage? Look, if it's at 6 volts and 2.4 is across this parallel combination, how much voltage will be here? Out of 6, 2.4 volt drop across all these parallel. So that will be equal to 3.6. So now you have the voltage, you have the current. Again, you will use the formula V is equals to IR. So you can see for one question, I use 3 times this formula V is equals to IR. So this is a very important formula in electrical circuits. The idea, the important thing is which value you will substitute. If you are finding resistance, voltage or current for a component, then you will substitute for a component. If you are finding for total, then you will substitute the total voltage, total current and total resistance. So this is 3.6, the current is 2 and the resistance we don't know. So 3.6 divided by 2, the total resistance will be 1.8 ohms. So this final answer will be 1.8 ohms. So what is the distribution of the marks? 1 mark is for identifying what is the total current. 1 mark is for identifying the voltage difference, the drop. And 1 mark is for using a formula and 1 mark is for the final answer. A similar question, because we discussed the previous question, it's a similar one. In the previous question, how it was connected, the resistor. It was connected like this. But now this is the same circuit. Now how it is connected next to it. So both are the same things. There's no difference between the two. So what happened? Like if this is a 12 volt example, I'm just giving example. If 3 volts drop here, so how much voltage will be there across 500 ohm?
6.
If out of 12, 3 volts drop here, how much voltage will be there across the
9.
500? So it will be 9.
6.
No,
So
9.
how 3 volt drops in both of the resistors, in 2 resistors.
But they are all parallel. Even if I have another resistor, that will also have
Yeah.
3. If there's another resistor, that will also have 3. But I will not say if all 4 are there, then they should be 0. That's wrong. Because what is the voltage across each individual resistor minus the total voltage, I will know how much voltage drop across the combination in series. This is actually a circuit which is a mixed circuit combination of parallel and series. Not only parallel. So this is a combination circuit. Okay, now the question is, a 12 volt battery supplies a current I. So there's a current I. The circuit contains thermistor. This is called a thermistor. And a 100 ohm resistor in 1000 ohm resistor in parallel and a 500 ohm in series. At a certain temperature, thermistor has a resistance of 1000 as well. Because thermistor is called a heat resistance. We will discuss this thermistor in detail about the circuit component, but just an intro of this thermistor. You can see it is therm and ester. Therm means heat and ester is from resistor. So this is a resistor which resistance changes with heat or temperature. So it is also called a heat resistor. So that's why they specify at a certain temperature resistance of a thermistor is 1000 ohms. So the resistance of a thermistor is given 1000. So 1000 ohms. Now they're asking combined resistance of thermistor and 1000 ohm. What is the combined resistance for these two only? They asked only for these two. What's the combined resistance? Their
1000.
product
2000.
divided, no, they are parallel. If they are parallel, the formula is the product divided by the
1.
sum. The product of the two resistor divided by sum. What's the answer?
500.
500. Because 1000 multiplied by 1000 divided by 1000 plus 1000. So it is a product divided by sum. So when you solve this, what you will get? You will get the total combined resistance, means this is now acting like a, when they're in parallel, we find the combined resistance, and what it shows, it means they're acting like a 500 ohm resistor. It is equivalent to a 500 ohm resistor. Is it clear? So when components are connected in parallel, the resistance, the combined resistance is product divided by sum. Now, the potential difference across 500 ohm. First, the current I means the total current. If I need a total current, I will use the formula V is equals to IR. I is the total current. You can identify the position that it's the total current which is coming in the circuit. So what is the total voltage of this circuit now? What's the total voltage?
12.
12. What is the total resistance of this circuit?
1000.
1000. Because the 500 and 500 are in series, so the total resistance not 500, that's 1000. So I will get the current, which will be 12 divided by 1000. What's the answer? 0.012. So the current here is equals to 0.012 amperes. Is it clear? In the question, thermistor resistance is given. You can see they mention at a certain temperature, the thermistor has a resistance of 1000. So its resistance is given in the question. So if you need, like this is 1000, these two are in parallel. So when you find a combined, it was 500. And this combined resistance is next to another 500 ohm resistor. So they are in series. That's why you will add. So the total resistance of a circuit will be 1000. So 0.012 ampere is what is coming from the battery. That will divide between thermistor and a fixed resistor, and that will rejoin here. So it's the same 0.012 ampere will pass through 500 ohm resistor. Because in the next part they ask potential across 500. How I'll, potential means voltage. So how I will get the voltage across this 500 ohm? So we will again use the formula V is equals to IR. So I have the current, which is 0.012, and multiply by 500. When I solve, multiply, it will be 6. Without calculation, this can also be done. How without calculation this can be done? As you know that two resistors, when I find the combined resistance of this part, the combined resistance of this part was 500. So you can see the two resistors have equal resistance and they are in series. So the voltage will divide equally. So if 6 volts is here, same 6 volts will be here. If this was a 20 volt supply, then 10 volts will be across the first one, same 10 volts across the second one. Because when two resistors having the same resistance, the voltage will divide equally. Is it clear, discussion? The potential across, but it's of 2 marks, so that's why I use a formula. But I can also use the theory to directly write the answer. But if I directly write the answer, means you will score only 1 mark for the answer. The voltage will divide if two resistors have the same resistance and they are connected in parallel. The voltage between them will divide. Like in the question, they ask what is the voltage across the 500 ohm resistor. That's the question, main question. So as we work out, we know the current was 0.012 ampere. The current will divide between them and then it rejoin here. So the current will rejoin as 0.012 ampere. So you have the current and you have the resistance. So you have current and resistance. You can use the formula V is equals to I R. So if this was current is 0.012, resistance is 500. When you multiply them, you will get 6 volts as the final answer. Is it clear, this part?
Yes, sir.
Yes, sir.
Figure shows another circuit which is a 6 volt, having a 6 volt supply. There's a 3 ohm resistor and unknown resistors of unknown value. We don't know the value. When a circuit is switched on, the ammeter reads 0.5. So if this ammeter reads 0.5 and two resistors are connected in series, how much current will pass through this one? What will be the current passing through 3 ohm resistor? So it will have 0.5. What is the current passing through unknown resistor? 0.5. What is the current leave the circuit? 0.5. Because the current in series is same. So all points I will have same 0.5 amperes. Calculate the value of unknown resistor. So we have to calculate the value of unknown resistor. How to calculate the value of unknown resistor? Because I have the formula V is equals to IR. To get the resistance, I should know the current. Current I already know, that's 0.5. But I don't know what is the voltage here because the voltage will divide. So how I will get the voltage? First, I will find the voltage across this one. What is the voltage across 3 ohm resistor? So how I can find V is equals to IR? Current is 0.5 and the resistance is 3. So 0.5 multiplied by 3, that's equal to 1.5 volts. So the total voltage here is 1.5 and they are in series. So the total voltage of a circuit is 6, but the voltage across 3 ohm resistor is 1.5. If voltage out of 6, if 1.5 volts is across 3 ohm, how much voltage is there across unknown resistor? So that's equal to 4.5 and 4. The current is 0.5 and this is 4.5. So R is 4.5 divided by 0.5. What I will get R? I will get that as 9 ohms. Is it clear? 9 ohm is the final answer. There's also a short method. Another method is there. I'll get the same answer. Look, first what I will do, I know the current is 0.5. I will find the total resistance of the circuit. To get the total resistance of the circuit, we know V is equals to IR. So total voltage is 6. Total current is 0.5. So I will find the total resistance of a circuit, which is 12 divided by 0.5 equal to, sorry, 6 divided by 0.5 equal to 12. So the total resistance of a circuit is 12 and they are connected in series. The total resistance of this circuit is 12 and these two resistors are connected in series. So means we know the combined resistance or total resistance is R1 plus R2. So total resistance of a circuit is 12. Resistance of first one is 3. Resistance of second one is unknown. Example R. 3 is added here. Other side it will subtract. What I will get? I will also get 9. So this is a second method of getting the same resistance of unknown resistors. So you can see the circuit, the formulas, even I have tried to find a different method, but I will get the same result or the same final answer if I'm substituting the correct values. Is this clear, this part? First, I got the total resistance of a circuit, and total resistance of a circuit, I subtract the resistance of the one component. So I will know the resistance of other component. As we know, when they are connected in series, the total resistance is sum of individual resistance. Calculate the charge passing through 3 ohm resistor in 120 seconds. So the formula, as we know, current is charge divided by time. The current was 0.5. The time is 120 seconds. I need a charge. So current is 0.5 and time is 120. 120 is divided, other side it will be multiplied. I'll get 60. And what is the unit of the charge? 60 ampere, volts, ohms. What is the unit? Unit of charge is not ampere. Unit of charge is coulombs. Unit of current is ampere. Unit of time is second. Unit of voltage is volts. Unit of resistance is ohm. Where unit of charge is coulombs. So capital C you will write. So 60 coulombs will flow through in 120 seconds. The rate of flow of the charges, like how many charges are flowing in 1 second. Like example, this is a wire and these are the charges, like example coulombs, the charges. So how many charges are flowing through a material in 1 second? So flow of the charges in a unit time is known as electrical current, but charge is denoted by Q instead of C, and the unit of the charge is C, which is coulombs. So there's a difference between current and the charge. Flow of the charge is called current. Calculate the power dissipated in 3 ohm resistor. So how to calculate the power? Because resistors are a component in which there is always a power loss. So power dissipated or power loss. How I'll get the power? I have the formula power is equals to VI. We already worked out the voltage because the current was 0.5. So when we work out the voltage, voltage was 1.5. So I know the voltage, I know the current, so I can find a power. So it is voltage was 1.5 multiplied by current was 0.5. So 1.5 multiplied by 0.5, what I will get? 0.75. And what is the unit of the power? So unit of power is watts, denoted by capital W. So 0.75 watt. Figure 8.1 shows a 240 volts AC main circuit. It is connected to a fan, a refrigerator, and a 60-watt lamps. Calculate the power supplied to the circuit. The power of the lamp is 1.2 kilowatt. The power of the refrigerator is 200 watt. The power of the lamp, each lamp is 60 watt. I need the total power. So what I will do, I'll simply add them. Power of the, when you find a total power for the circuit, you, or even it's a parallel or it's a series, because power is how much energy transfer in 1 second. So you will always add them. So what is the power of the fan? It is 1.2 kilowatt, means 1200 watts. This is 200, 60 and 60. What's the final answer? 1200 plus 200, 1400 plus 120, 1520. So 1520 watts. They are all connected in parallel, and there's no other component next to them in series. So now if they are all connected parallel to battery or supply, so this will also receive 240, this will receive 240, this will receive 240, and this will also receive 240. Why? Because there is no other component in series to this parallel component. This is a pure parallel circuit. That's why they all receive the same voltage. The appliances are connected in parallel. Explain what connected in parallel means. What's the meaning of parallel? So how you explain? Multiple ways for the charges to flow, or separate connection for each component. Not next to other, it's next to other is series. Connected in parallel means separate connection for each component. And multiple ways for charges to flow. The reason why I use the term component, because this circuit is having fan, refrigerator, lamp. So different types of electrical components are there, or devices or appliances. That's why I specifically use the term component, not lamp. If it all were lamp, so then we can use that. The next part, state two advantages of connecting the appliances in parallel rather than in series. What are the two advantages for connecting them in parallel rather than in series? The advantage number one, because they are in parallel, so they all receive the same voltage. Same voltage across each. And the second advantage, they will work independently. Work independently means if one of the component is a faulty, then the other components still continue to work. How it's an advantage that they receive the same voltage, but otherwise, for example, if I was having them in series, I was having a 240 volt supply, then there was a fan, the refrigerator, the lamps. So if all of them are connected in series, say this was a fan, a refrigerator, lamps. So if this was 240, maybe the fan uses, example, out of 240, the fan uses 100. Then refrigerator, or out of 240, the fan uses say 50 or 60. Then this uses 120. Then this lamp uses 30, the other lamps also use 30. So voltage, the energy is divided between the components. Why this is a disadvantage? Because our devices, the circuit appliances, they are all working efficiently. They required energy of 240 volts or 220. So, but how I can, when they're connected in series to a 240 volt supply, it is impossible that I can supply a 220 volts or a 240 volts. For working of each component, I need minimum 240 or 220. But here, when they're connected in series to a 240 volt supply, the voltage will be divided. If the voltage will divide, I cannot work, or devices may not work properly. That's why when we connect them in parallel, they all receive the same voltage. So that's an advantage of a parallel circuit. If I want to supply a same voltage, so connecting them in parallel, in the next part, the current in refrigerator. You know the power of refrigerator, the power is given, the voltage is also 240. How to find a current? You have the formula P is equals to VI. So power is how much? It's 200. Voltage is 240. You need a current. What's the current? 200 divided by 240. So the current in the refrigerator is 0.833. the energy used by the fan in 3 hours. So power is in, as we discussed in block 1 general physics, the power is energy divided by time. So we need energy, so energy will be power multiplied by time. Power is also having a formula, energy over time. So energy is power multiplied by time. You have the power of the fan. The power of the fan is given 1200 or 1.2 kilowatt, and the time is in hours. You have to convert into second. So you have to convert 3 hours into second. So first you'll multiply by 60 to convert into minutes, and then you multiply by 60 to convert into second. What's the answer? The final answer, power multiplied by time. Power is 1200, as you can see in the question. For a fan, 1.2 kilowatt, which is 1200. And the time is in 3 hours, so you have to convert into second. Multiply them. 10,800. So this should be 60 multiplied by 60 multiplied by 3 multiplied by 1200. Yeah, it is 1.2. And joules will be there. This, when you multiply them, this is 10,080 or 10,000, sorry, 10,800. That's seconds, and multiply by power, power multiplied by time, 1200 multiplied by 10,800, you will get 1.2 exponent 1 2 3 4 5 6 7. So 1.2 or 1.3, basically 1.29 exponent 7 or 1.3 exponent 7. Resistance of a filament. So how to find a resistance? You know the voltage. First you have the power, and you have the voltage, which is 240. You will find the current P is equals to VI. So power is equals to 60. Voltage is 240. So you will get the current 60 divided by 240. It will be 1 by 4 or 0.25. So current is 0.25 amperes. Then find the resistance. V is equals to IR. So 0.25, voltage is 240. What's the answer? R is equals to 240 divided by 0.25. So 240 divided by 0.25. What's the final answer for the resistance? That is equals to 960 ohms. Is it clear? So this was 960 ohms.